Hello and welcome to Captain Bob. Today I'm going to show you how you can make this flaps module.
For this build, you'll need this potentiometer, these 3D printed parts, these two M3 20mm screws, these two M3 nuts, a servo, and a decal. You'll also need one 8mm M3 screw. Let's start off with this faceplate. The faceplate requires a decal, and these are printed on vinyl paper. I'll usually hold these up to the light so that I can align these white holes with the holes right here. The text should be right side up, and then this wider part of the notch should be at the top. Sometimes you can put the decal down, lift it up a little so that you can expose the holes. You can also use your phone's flashlight to illuminate the holes. Now you can get an X-Acto knife and scissors and cut the edge and the center holes. Now I have the first slot, and we can do the second slot. We can use the edges as a guide, and always be careful where your fingers are. If you don't really like how the corners turned out, then you can add a little bit of Sharpie. I actually like how a little bit of white showing sometimes for weathering effects kind of makes it look a little bit older, like most Cessnas are, like in a flight school. Now we can get this potentiometer, place it in this hole. There's a little notch where this bump right here goes. And then screw the nut and bolt back in. Now we have this potentiometer knob. Let's turn it all the way right and then back off just a little bit so that we see right here this notch right here is straight up. This potentiometer arm, you can add an M3 8mm screw right here. Push the arm through, make sure it's all aligned, and push this part onto the potentiometer. Now confirm that it hits the top right here, the actual plastic piece, instead of hitting the limits of the potentiometer. Once you're happy with this, you can screw that down. This is great. Let's put this handle on. But you'll realize that it doesn't really feel too great though. It feels really loosey-goosey. That's where the friction plate comes into play. So this friction plate has these two M3 screws. Now we have this friction plate. We can place it over the potentiometer like so, and then push the first one through, and there are these little access holes here into the threaded plastic. Into the plastic, then you can screw them in from here. And this is also how you'll adjust the friction once you're all finished. On the other end, this will accept two M3 nuts right here. This will help give it metal threads and last longer. This friction plate will engage with the potentiometer leveler right here. As you tighten it down, you can add more or less friction, depending on how tight you go. I recommend making sure that these are tightened evenly. Now last we have the, what's it called? Now I have this servo and this servo needle. We'll attach this like so. For now, we're going to keep it loose until we get into MobiFlight. Okay. Now we can put it into the flaps mechanism and go from there. After we have this dialed in, we'll use the small screw here to screw it in, and then the two slightly larger screws to screw it into its housing.
For the flaps panel, we're going to solder these black, white, and red wires to the potentiometer. This first one's going to be black, then white, and the last one is going to be red. This black wire is going to be your ground, so it'll go on GND, wherever you see a GND on the board. This white wire is your signal wire, so it can go on any of the analog pins. They start with an A, so AO through A15. We'll start with AO. And then this red wire will go to 5 volts. Red is positive for power. For the servo, we're going to use these DuPont connectors. In my case, I extended these brown, red, and orange wires with a male-to-male brown, red, and orange set of wires. The brown goes to ground. You can think of it like dirt. The red goes to 5 volts. And then this last one can go to any pin that you can assign in MobiFlight. We're going to start off with pin 2. That's the first available pin. Now let's just tidy it up a little bit. Okay, let's start out in MobiFlight. We have a blank configuration, and we're going to start out with the stuff you need to do for both simulators. You need to go to MobiFlight modules under here, and you might have to upload or update your firmware to your Arduino. Once that's done, you can add a servo, and we wired this to pin 2. We'll call this flaps position. We'll also add, you can right click here or add through this menu here, an analog input. This is our potentiometer. Going to assign it to AO, that's the one we wired. This is going to be flaps input. Now let's click upload, and we're good to go. We're going to create an input config called flaps input. Okay, now is when it branches off. We have 3 methodologies. We have Microsoft Flight Simulator 2020, the easy way, Microsoft Flight Simulator 2020, the hard way, and X-Plane. Those are the 3 I'm going to cover here. Files in the description below for these. Okay, so flaps input. So we'd like to see what position the flaps is at right now. So let's go into extras, settings, general, and click enabled for logging to a debug level right here. Now you'll see this window right here, and whenever we change something, for example, our flaps position, like I'm doing now, you'll see the numbers change. We're going to read the smallest and the largest values. 363 is the largest, 157 is the smallest. 363, 157. And I wrote these right here for reference. Now, for the easy one, we have this hub hop button right here. We can press it, and we'll visit the hub hop MobiFlight website. Under tools, there's this really helpful tool that Jamie, I believe, made. And it's the potentiometer RPN tool, reverse Polish notation. Yes, reverse Polish notation. So, under device output range, select Arduino. And under Microsoft Flight Simulator event range, select flaps. Now the minimum output range is 157 for all the way up. 157. And the maximum is 363. We have this code, and we're going to now implement it into MobiFlight. So click on Edit, find your Arduino with your flaps input, and under Microsoft Flight Simulator 2020, we're going to skip all of this stuff. We'll do that in the next segment, the next option, and just show preset code. Copy this over and paste it here. And now if we're in our flight simulator, which is loaded up through the magic of editing, now if we make sure the simulator is running and MobiFlight by clicking run, we can see that right here, it's lining up. And it's lining up pretty well. This is great, but you don't have a ton of control with this. You can squish the bounds a little down so that the lower steps are all closer together. But other than that, you can't really do what you want to do with it. To keep everything separate, let's do this in a separate file. And we'll make a variable called flaps output, or input. Click edit. And a handy thing you can do is press scan for input and then move this lever. It'll automatically fill in flaps input right here. Under action type, now we're going to do MobiFlight variable. So this variable right here, myvar, let's name something more intuitive. Let's name it flaps potentiometer right here. And the value is going to be at. This @ sign is the input value of the potentiometer. So this is basically just reading what we have down here. So like these numbers when you rotate the potentiometer. Click OK and go under output configs. Let's make a new row, and this will just be flaps right. Now this is some slightly more advanced functionality of MobiFlight. Usually you keep all the inputs in the input field and all the outputs in the output field, but this time we're doing some of the inputs in the output field. We're going to go to flaps right, click edit, and under here we're actually just going to read the simulator variable, the MobiFlight variable here. Under the drop down we have flaps potentiometer right here. Now under this, if we click run, it just outputs our value. So 157, our minimum value, all the way to 363, our maximum value. So that's great, but how do we get that into the simulator? That's where we come into the display tab. So under this, instead of output device, we'll use this in a second for the servo, we're going to do input action. So now on change, because this is a potentiometer, whenever the potentiometer changes its position, this on press on release would be used for a switch. On change, we're going to go to Microsoft Flight Simulator 2020. Here's where you would add your flaps. We have flaps here, flap here. It says flaps handle to closest increment 0 to 16383. This is what the simulator actually reads, this 0 to 16383, but the flaps potentiometer reads 0 to 1024. This says intended for analog input and custom input box. Reading between the lines, you can tell analog input means, in Arduino, means 0 to 1024. This is 8-bit precision. No, it's 10 bits. So now we need to get these values, 363 and 157, into 0 to 16383. Let's do that in the compare tab. In this case, our very minimum input value is 157. This is the minimum our potentiometer will read. Now our maximum input value will be the maximum the variable can be, the maximum the potentiometer can be, 363. So now, if we input a value of 157, it outputs a value of 0, and if we input a value of 363, our maximum, it outputs the theoretical maximum of 1024. If we click OK, we can see this in action right here. It went all the way up to the top, all the way down to second when we're in our first position, all the way to third, it looks like. Nope, not to third, and now to fourth. So it looks like it's skipping a little. Now this is where we have the fine control. What I'm going to do is add this stop right here, and it'll be at 277, this first stop. So that's the physical first stop. We're talking about our potentiometer value, 277. When our potentiometer goes to that first stop physically, we're going to add that row 277. And that's going to give out a value of, we'll have to calculate this. So we have 1024, that's our output range. There are 4 positions, which means 256 should be our first base, 256. It's looking like that's getting us there. 0 to our first 10 degrees. And now if we step it down, we'll go to our next 10 degrees. And finally, we have our full. So that did the trick right here. Now the flaps travel all through its range. But how can we tell it's traveling through its range? Let's do the servo now. We're going to start with the servo outside of the flaps module. We're going to go create an output row. This output row will be flaps servo. I know I'm really original here, but this flaps servo, click edit and go to sim variable. This time we have it a lot easier. Under sim variable, we're just gonna read the sim variable. This will be flaps, click generic, because it's a generic event, and then flaps handle index or percent. Index gives you the current flap position. If I went here, and then went to flaps 1, it would be 1, flaps 20, and flaps full. So that's how that works. 0 to 3 for all 4 positions. And flaps handle percent here. This one might be this one's more versatile. You'll go flaps handle percent here, and this will go output a value from 0 to 100. You'll have to multiply it by 100. It'll go 0 to 1. And we're going to do exactly that. Under this checkbox, we're going to say transform times 100 to get that 0 to 1, from 0 to 1 to 0 to 100. That'll just be easier to work with. Now, under display, we're going to use our output device, our Arduino, and our servo. So right here we have this, and if we click test, you'll see, oh, you have to stop this before you click test. I always forget that part. If you click test, you can see it going all the way 180 degrees about, which is 120 too many. What we're going to do is press test and then press stop. And once we press stop, it returns to 0. And we know this is the 0 position, so we can push it on the lever. I think about 30 degrees from the horizon is the ideal measurement. You can always adjust it in a second. If it's making this struggling noise, then that means you did it too high. So maybe 25, 20 degrees. You can push it on there and try now. That looks about perfect. You don't want it to touch the top because it'll make that struggling noise. You want it to be just a little below. And this is actually perfect. Let's use the smallest screw right here. Whoop. Just to screw that down. And you'll want to check afterwards so that screwing it down didn't actually mess it up. And let's see. Yep, it's still in the 0 position. That's perfect. And now we have these 2 screws right here that we can use to mount this to the panel. I actually prefer to hold off on mounting this servo until I need it in my panel, because this servo comes off before you mount the flaps handle assembly into your panel. So you just plop it through the panel, and then afterwards put the servo piece in, like so. So I'll do this once I install my panel. For getting everything ready, it just fits in and it should be good to go. You might be tempted to press test, but I would advise not putting it at 100%. Remember, the servo has a 180 degree travel, but the flaps slot has about anywhere from 40 to 60. I forgot the actual number. But our maximum rotation is going to be, let's start off conservatively at 20 degrees. 20. Okay. So 20. How you can get the number of degrees to this maximum rotation is by taking your number of degrees, so let's say 30, and multiplying it by 100 divided by 180. This is 100%, and then you have the scale factor to get that into 180 degrees. So this will give us, if we just want to have a stepping place, this will give us 16%. So let's have a maximum rotation of 16. We can test this and realize it gets us to 20. So probably a little more. Spoiler alert, it's 22. Maybe 20 even. You just don't want that high-pitched hum of the servo because that means it's pushed beyond its limit. You want just a little bit of space between the tops and the bottoms. Now let's click test. And it goes from 0 to 30. That's great. Good news. So I guess I was a little off. It's 20, not 22. Now the minimum value is 0 and the maximum value is 100. Because the minimum value of this variable is 0 and the maximum value is 100 as we tested earlier. So click OK and click run. And I'm pretty sure it'll work. Ready? That's awesome. This does give us the flaps handle degree though, which is slightly useless because we have a flaps handle. So we're instead going to use the sim variable trailing edge flaps left %. Why left trailing edge %? Both flaps retract at the same rate unless you have an asymmetrical flap situation, but at that point it'd just be easier to look out the window and realize that one of your flaps is bent upward somehow. Aileron wannabe. So if we switch it over to that, now it'll lag behind the flaps handle. Here it's at 20, and now it's at 30. And all the way up. Look at that, it matches. Isn't that great? So we have this all set for Flight Simulator 2020. Let's go on to X-Plane. For X-Plane, we're going to do the same exact thing, except for it's going to be in X-Plane instead. At least X-Plane doesn't make really annoying noises whenever it starts, so that's good. But it does freeze up, like every time you load it. Oh well. Now for X-Plane, we're going to do very similar steps to the Microsoft Flight Simulator Advanced version. We're going to go into input configs, and we're going to make a flaps input row. Click edit, and then scan for input, move the handle. Action type, we're going to do a variable again. This will be flaps input. We're going to have it set to the @ sign for the input value. Alright, and then over in output configs, we're going to first have the flaps right, and then this, we're going to first read the variable from our input, MobiFlight variable, from the drop-down flaps input, click OK, and then as soon as we press run, you can just see that this is the same exact value as is displayed in the logging window right here. Sweet. Now let's go click edit again, and under display is where all the magic will happen. So let's go output device. Instead of output device, we'll go input action and on change, because this is every time the number changes to a different number. It'll update the configuration. So on change, we're going to go to Microsoft, nope, we're going to go to X-Plane right here. I hope I don't need to explain why. Under search, we're just going to type in flap. We're going to narrow it down through our aircraft and click generic. We want something that'll work for all aircraft. And generic is usually the way to go unless you need to specialize. And we have 168 results. Woohoo! Let's go under here, and I know that it is flap request. Flap request. This is request flap deployment. How do I know this? I sat in my chair for like 10 minutes just tinkering around. But the way you can find this is by getting the data ref tool. I'll link to it in the description below. I typed in flap, clicked this CH button to scan for change, and then I moved this flap handle, and I realized that this 0 and 1 matched up with this handle right here. Could use cockpit, sorry, it's in colorblind mode. Cockpit 2 controls flap ratio here. That one works, or flap request here. You in this little box in the data ref tool, if you click 1, press enter, it'll go all the way down. If you click 0 and enter, it'll go all the way up. 0.33 is middle, and 0.66. That was kind of depressing. We'll go right here. That is awesome. We're right on. Let's try this out. And I kind of feel like I know it's going to happen. Okay. It's not going to do anything. Why? It's exporting a value of 160. I kind of wish the flap went all the way down. Sometimes. Ah, there we go. Yeah, if you have a value greater than 1, it'll actually go down below its limits, which is kind of funny. I wonder what that looks like for the flaps. But you can see our flap handle and our flap needle are not where they're supposed to be. So just make sure the bounds are 0 and 1, and I'll show you how to do those right now. So the value, so you set these bounds in the compare tab right here. Click interpolation settings on, and our minimum input value that's getting read through this input variable right here is 157. That's our top range of the potentiometer, and our maximum is 363. That's our bottom range of the potentiometer. Our output is 0 for all the way up for the flaps, and 1 for all the way down on the flaps. Now every value between 157 and 363 will get interpolated into a value of between 0 and 1. So it'll be like 0.33 if it's wherever it needs to be. 0, 1. That's not what we want. It is in between the bounds 0 and 1. It won't ever get greater than 1. But it's not what we want. What we want is to multiply this by 100. 100, add 2 zeros right here, 2 zeros here. And then under flap request, let's click show preset code so we see all of this fancy stuff. And let's use for our value, our input value of our at right here. Is this working? It kind of is right here. If we put it all the way up, it goes all the way up. And if we put it all the way down, we didn't even put it all the way down. We put it into 10 degrees. It just jumps all the way down. This is, I believe, just a rounding something. This is because it doesn't have enough precision. It's either all the way up or all the way down. We want it to be somewhere in between. So we're going to multiply this interpolation value right here, this output value, by 100. I like to just add 100 just for peace of mind, even though it immediately deletes. See? Can't win them all. 100 times more accuracy. You don't need a ton of accuracy with this because it's by nature it's a very imprecise instrument. We just multiplied it by 100, so we need to divide it by 100 here. So let's click OK and click save, and let's try it out. All right, we're at our first stop. That's good. We're at our second stop. That's good. And we're at our third stop. That's good. Let's briefly retry our first stop. So it looks like it kind of skipped over the first stop. Right now it's outputting a value of 0.57, which is no bueno. So what we want is whatever value. So what we want is the value of this first stop. And we can find that using the logging right here. Put it at the first stop, and this first stop value is 278. Okay. All right. So add a new row. 278 will go to 33. All the way up, down a notch, that puts it at 10. Down another notch, that puts it a little below 20. We can adapt this. 329. Ready? Let's edit this. Add a new row. 329 will give out a value of 66. And yeah, that fits to this 20. And now all the way down, of course, should give a full value. So that is how we put in our different values. What is this witchcraft? What are you doing? Okay, so what I'm doing, I'll explain it just to be clear, is we're putting the minimum, our first stop right here, all the way up, reading it from our logging window, or this flight sim value window. And that is 0 or up. And that matches here, this flap request 0. Now the second position, that is this 278 value right here, 278. And this gives you a value of 33. And this is this 0.33 right here, this right here, this 10 degrees. And this 0.33 is multiplied by 100 to get 33. Because we want, instead of going 0 to 1, we need to multiply it by 100 to get more accuracy. This 329 is doing the same thing. And your numbers will probably be slightly different. Yeah, this 333 is close enough. Gives out a value of 66. That's this next value right here. And then 363 gives out a value of 100%. Then to get it into that 0 to 1 slot, we just divide it by 100. And I use this @ sign right here to get the input value from this variable adapted for the interpolation station. Cool. All right, click OK. And now our last thing we have to do, I don't even have to delete this row, the reference row. The last thing we're going to do is flap position. We're gonna call it that. Click edit, and under sim variable, we'll go to explain data ref, and we're going to find one of the variables that lags behind. So this is one that lags behind. For some reason, I just like the ones with nice names, like short names. Makes it easier to comprehend. But we found right here, sim flight model. Ironically, the colorblind mode makes me not be able to see the color. But flap rat, I think this is flap ratio. I love all of the codes in flight sim. Like everyone's like, no, it's rat, not ratio. If you're spelling out the word ratio, you're wasting millions of years of your life. So flap rat right here, we'll search flap rat. Kind of felt like that'd work. Just do it the old-fashioned way. Generic flap. Flap deflection. Yeah, flap rat right here. Actual deployment. Now we're going to do the same thing under compare. We're going to say if it's 0. Okay. Actually, we're going to do a similar. Okay. So this is from a value of 0 to 1, and it goes from 0 to 100%. I don't think we need to do anything here. We can go output device, our video Arduino, and use our servo, our flaps position servo. Let's just have a maximum value of 1. That way we don't have to multiply everything out. Max rotation, I believe, is 20 from last time. Stop the simulator so it doesn't have to be wherever it needs to be. Click test, and 20 works great. If you want to have the math, it is 40 degrees, that's how many degrees it is designed for, times 100 divided by 180, and that gives you 22. I guess it's more like 35 in this version. So 35 degrees goes into 20, so great. Now let's test it out with a 1. I'm actually not sure if this will work or not, so let's go. All the way down. Hey, it didn't really work. Let's multiply it by 100 to get the same exact thing. We can even just use a transform. 0 times 100, or $ times 100 here, and then under display, maximum value will be 100 right here. So now, if we click run, 10 degrees goes to 31%. That is pretty good. Now down more goes to 20%, 20 degrees, sorry. And then down to the last notch, goes all the way down. Let's go. And there we have it. We have our working flaps handle. Zoom. The needle lags behind the instrument, and that makes for a very fun time. It's fun to kind of freak it out. It's like, what am I doing? What? I guess I'm just bullying the flaps lever at this point. I guess I did cover up. Okay, so now it's working. Ready? It coordinates exactly to this flap handle right here. Ta-da! It's fun to mess with the flap lever. You're just kind of bullying it, and that to me is fun. I guess I'm bullying aircraft parts, which is a kind of strange hobby, but to each their own. Thank you so much to Patreon supporters for helping support this channel. If you'd like to join Patreon, there's a link in the description below to help support builds like this. I really hope you enjoy this addition to your flight simulator, and have a fantabulous rest of your day. Stay spicy.